It is important that you consider how much load is actually on the chain and the gear that you're using, because not everything is as it seems. Particularly for the chain that's on an extreme angle holding up a load. We just calculated that this is an 800-pound load and is held by some chains. The part of the hardware that is holding it on vertical looks like so, and it consists of wood on edge, hooks, shackles, some heavy-duty chain, more shackles, a winch, more shackles and chains. So let's start at the load, and then we'll work our way back to the anchor point. First off, the load has to be hooked up in a secure manner. As it is, you can see that it's not gonna slip out from this kind of four-legged bridle hitch that I tried to make here with the chain. So the load is hanging securely. Step 2. I needed to make sure that the chain is evenly loaded. The chain is not twisted. It's running nice and straight line, and this is how you use the chain with this hook that it comes with. Here is the other one. Everything has pins, cotter pins, as it comes from the manufacturer, so it's in good order. It's important that this chain, the chain's capacity be known. It's a grade 70 transport chain or 5/16 chain, and I have to match it with 5/16 shackles, 5/16 hooks, 5/16 everything. You can see that on this one the working load limit is 4,700 pounds or 2,132 kilograms. The working load limit is not its braking load that it can carry. It has a safety factor of 2, 3, maybe 4, I don't know, but it's not its braking limit, okay? It's a little bit stronger than 4,700 pounds because there's wind and loads move, and when they do so, there is more stress on the chain. For example, if this load was to tilt this way down, then out of the 4 legs of this hitch, only 2 lengths of the chain would carry this load. The other 2 would not come entirely slack, but for safety reasons they are considered not carrying the load. So for the calculation, I'm gonna be working with only as if 2 lengths of chain would hold this one up. 400 pounds there, 400 pounds there, because this is an 800-pound slab. I just calculated. After the 800 pounds slab, here is this black item. It's a 5/8 shackle. It's on a hook. The hook is attached to this part of this come along or winch. This is a 2-ton winch. It's an imperial ton, so it's a 2,000-pound winch. Because it's loaded vertically, it's perfectly fine. On this side of the winch, you can see some shackles in an interesting configuration, and the anchor point. You can see that the chain is not twisted, but the pin of the shackle is going through the hook that's holding the winch, and none of the chain links are twisted. They are all lining up neatly, and that's how it should be. I know this one is in the shadow. You can see everything has its twist pins and everything in place, and this chain is bigger and thicker than this chain. If this was grade 70 transport chain with a 4,700-pound capacity, this one, the 1/2-inch chain, is even stronger. There are grades of chain, and I'm going to show you in the classroom, and different grades of chain have different working load limits and braking strengths as well. So, but generally, if it's thicker, it's got to be stronger. Okay? we're gonna do some math in the classroom, because the anchor point and the winch are loaded vertically, so their working load limit is considered straightforward. Whatever is printed on them, that the face value, that's what you can work with. However, the chain is on an angle, and it has a greater load on it than 800 pounds. I know it's a little bit of a mind boggler. How can it have more than 800 pounds of load on it when the slab is 800 pounds? But for now, before the calculations, let's just go with the shopping bag analogy. If you overstuff a shopping bag and the loops on a shopping bag, plastic bag, are on too much of an angle, you know that it's gonna rip right out there at the corners. Okay, so, and I'm gonna show you in the classroom with force gauges that a piece that's 800 pounds or 80 pounds or 8 pounds can actually place a load that's 2, 3 or even 10 times as great as the weight of the slab that's being lifted in the first place. Okay, so that's my setup here for lifting. You be safe.